So even before we start reading the question, I want to go through something that you might already know, but I just want to make it very clear. So let's say if you have 3 equations, then how many unknowns can you have? Okay, if you have lesser unknowns than equations, that's okay. If you have the same number, that's still okay. What is not okay is when you have more unknowns than equations. So let's read the question now with this concept in our mind. It says a GS has first term A and sum to infinity 5. Usually I like to refer to this as one piece of information. Reading the second sentence, the first and second terms of the GP are the second and third terms of an AP. So that's 2 pieces of information. Given that the sum of the first 10 even number terms of the AP is -8. I have 3 pieces of information and I need to show that A is equals to 1, meaning that A is one of my unknowns. Working on the first one, right, sum to infinity is 5. That means A over 1 minus R is equals to 5. And then instead of writing this as equation 1, I wrote this as equation 1 instead, right? Why is that so? Okay, so if you have, say, a question with 3 unknowns, and inside here you have 3 different variables, which I know will be A, R, and maybe the third one, let's just call it X, right? Since I don't know what it is at the moment, I can swap this out into 1 minus A over 5. I managed to reduce to only 2 unknowns, A and X. Okay, so this is a technique that we're going to use. If I want to find out what A is, then I want to write the subject of the formula as something that's not A, because I want to replace it away. Now let's look at the second piece of information that I have. First and second term of the GP is second and third term of the AP. This is where I think students might make a very important mistake. So if you look carefully at how I write my AP, it's a bit different from how you usually write an AP. I could have written my AP this way. Guess what? I will have 4 unknowns because I already have A, I already have R. If I introduce B and C, that is 4 unknowns. Okay, and then that's something that I will never be able to solve given the amount of information from this question. The question told us that the first term of the GP is equals to the second term of the AP. Right? If they are the same, then I'll just write both as A. Then maybe the first term of the AP will have to be A minus D. We had to do it this way so that I can keep to 3 unknowns, which if you look at the question now will be A, R, and the common difference D. AR equals to A plus D. Okay, and you can see what I wrote as my final form for my second equation is very consistent with the first one. Because I'm looking to substitute away D, I'm going to make D the subject of the formula, right, for my equation number 2. Okay, given that the sum of the first 10 even numbered terms. Okay, this is also something new that you might not have seen before, or term number 2. Okay, so this looks strange. This might look like the first term, but it's not, remember. The first term of AP is actually A minus D. Yeah, take some time to digest that. List it out if you have to. List out the whole AP, starting with A minus D, A plus D, A plus 2D, A plus 3D, so on and so forth. Then you can start to see where are your even numbered terms. First term, and this is the last term. Right, so it'll be n over 2 times first plus last term. Okay, and we know from the question that this is equals, this thing is equals to -8. So let me put the -8 on the left hand side. And you should be able to come up with something like this. -8 over 10 equals A plus 9D. So the first thing I'm going to do is I'm going to substitute in D, right? So that hopefully I will have no more D. But in the process of substituting D, you realize that I introduced R. So no problem, I can substitute equation number 1 to get rid of R. And after substituting both equation 2 and equation 1, I have a equation purely in terms of A. I would be able to solve for A. But eventually you should get something like this, a quadratic equation, right? And then you have 2 solutions for A. Now the question tells us that show that A is equals to 1. So some of you might be tempted to say that, okay, yep, I managed to show that A equals to 1, but that is actually not sufficient. You still need to prove why we're going to reject A equals to -4 over 9. If you haven't figured it out, maybe you can pause the video at this stage and see if you can find out a reason why we should reject A equals to -4 over 9. If you substitute A equals to -4 over 9 to find out what our R is, you get R equals to this, 49 over 45. Okay? And since we have a sum to infinity, then mod R needs to be less than 1. In this case, this is greater than 1. So since the mod R is greater than 1, then the sum to infinity does not exist. And therefore, I'm going to have to reject A equals to -4 over 9. Okay, but if you substitute A equals to 1, you find that R is less than 1. And then, therefore, you would have a sum to infinity. So that's how we're going to show part 1, that A is equals to 1. Alright, so let's look at part 2. Hence, find the smallest value of n such that the product of the first n terms of the GP is less than 10 to the power negative 10. Okay, so we have to be careful. It's the product of the first n terms, not the sum of the first n terms. Meaning I want A times AR squared times AR to the n minus 1. Quite different from what we do usually. Yeah, so A will be 1, AR will be 1 times 4 over 5, AR squared will be 1 times 4 over 5 squared, and I want this to be less than 10 to the negative 10. Okay, so if I were to multiply all this together, it will be actually equals to 4 over 5 to the power 1 times 4 over 5 to the power 2 times 4 over 5 to the power 3, and that's the same as adding 1 plus 2 plus 3 all the way to n minus 1. So we kind of have an AP happening over here in the exponential space. If you sum this up, you will get this. n minus 1 over 2 times n, right? Just use the rainbow method, right? Here, what I need to do is I need to take log. Usually I'll take natural log, but in this case I'll take common log, which is log base 10. Why am I taking log base 10? Because if I take log base 10 of this, then you realize that this thing is equals to 1. So that explains this side why this is negative 10. And on this side, when I take common log of this, again I can move the power down, right, to the front. And then what I'm going to do is I'm going to change this into 0.8. Okay. So here's one thing you always need to remember for H2, and that is log of anything less than 1, okay, will be a negative number. Why is that important? Because the inequality sign will have to change when you multiply or divide by a negative number. So n over 2 n minus 1 will be greater than negative 10 over this. And then you would have a quadratic equation over here. Okay, and because this quadratic has a positive coefficient of n squared, you'll be a smiley face. Okay, and you can use your GC to solve for the roots. Okay, there's 13.9 and 14.9, and I want the parts of the graph where it's greater than 0. So I'm looking at these portions over here. Okay, and because n has to be a positive whole number, and therefore I'm going to have n greater than 14.9, and the smallest n will then have to be 15. And so that's the end of this question. Hopefully you found this video helpful, and I'll see you in the next one.